Hello everyone. Today we are going to discuss the chemistry question paper for JEE Mains 31st January 2023 evening shift. Let's start. The first question given to us is, which of the following elements have half-filled f orbitals in the ground state? Let's see. The A element given to us is samarium. Its configuration is 4f6 6s2. The second element given to us is europium. Its electronic configuration is 4f7 6s2. Third given to us is terbium. Its electronic configuration is 4f9 6s2. Next given to us is gadolinium. Its electronic configuration is 4f7 5d1 6s2. And the next given to us is promethium, PM. Its electronic configuration is 4f5 6s2. So they have asked us the half-filled f orbitals. So we have half-filled f orbital, which means 4f7 in option B and option D, which is europium and gadolinium, option B and option D. So our answer will be option second, which says B and D only. Moving to next question. Incorrect statement for the use of indicators in acid-base titration. Strong acid versus strong base titration. In this titration, the transition range, phenolphthalein is a suitable indicator. Phenolphthalein having an indicator range of 8.3 to 10. That is a suitable indicator for the transition range of strong acid versus strong base titration. Weak acid versus weak base titration. It has such a small transition range that methyl orange having indicator range 3.1 to 4.4, that is not a suitable indicator. This is an incorrect statement. Then it is asking for a weak acid versus strong base titration. For this titration's transition range, yes, phenolphthalein is a suitable indicator. Then we have strong acid versus weak base titration. For strong acid versus weak base titration, methyl orange, yes, it is a suitable indicator. So they asked us about the incorrect statement. Second option, this is an incorrect statement here. Next question, in the following halogenated organic compounds, the one with the maximum number of chlorine atoms in its structure. For that, let's make the structures. First is chloral. Chloral is CCl3, CHO. Second is chloropicrin, which is CCl3NO2. Third is freon 12, which is CF2Cl2. And fourth is gamexene. So when we see the number of chlorine atoms in all of these four compounds, in first we have 3 chlorine atoms. We have 3 chlorine atoms. In chloropicrin, we again have 3 chlorine atoms. In freon 12, we have 2 chlorine atoms. In gamexene, we have 6 chlorine atoms. That means when they are asking us with maximum number of chlorine atoms, our answer will be option 4th, which is gamexene. Next question, given below are two statements. Statement 1 is H2O2 is used in the synthesis of cephalosporin. It is given in NCERT. Yes, it is a correct statement that H2O2 is used in the synthesis of cephalosporin. Next statement says H2O2 is used for the restoration of aerobic conditions to sewage waste. It is also given in NCERT. Yes, it is a correct statement that H2O2 is used for the restoration of aerobic conditions to sewage waste. So our both statements are correct. Let's see the options. Correct option will be third option, which says both statement 1 and statement 2 are correct. Next question. Given below are two statements. One is labeled as assertion and other is labeled as reason. Assertion statement says the first ionization enthalpy of 3D series elements is more than that of group 2 metals. Ionization energy, the first ionization energy of 3D series elements is more than that of group 2 metals. It is a correct statement because when we move from group 2 metals to 3D series elements due to introduction of d orbitals, which has a poor shielding effect, the ionization energy increases. The reason statement states that in 3D series of elements, successive filling of d orbitals takes place. It is a correct statement that yes, in 3D series of elements, successively d orbital electrons starts filling. But it is not the correct explanation for the given assertion. The correct explanation is due to introduction of d orbitals, d electrons, which is poor shielding. Due to that, ionization energy increases. So answer will be option 4. Both assertion and reason are true, but reason is not the correct explanation of A, assertion. Next question, compound A, C5H10O5 gives a tetraacetate on reaction with acetic anhydride. It gives a tetraacetate, which signifies that this compound has definitely 4 OH groups. Correct? Next, they say it gets oxidized with bromine water to give an acid, which indicates that this compound has aldehyde group present. Then the next information states that on reaction with HI, it forms isopentane. What is isopentane? This is isopentane, correct? So that means that a straight chain compound C5H10O5 is not possible. It is not a straight chain compound. If we find these 3 requirements in these 4 options, option 4 is the suitable option, having aldehyde group, having 4 OH groups, and also it is not a straight chain. On reduction with HI, it will form isopentane. Let's see the products of this compound. On reaction with acetic anhydride, this will be the product obtained. When we oxidize this compound with bromine water, we get a carboxylic acid. CHO groups gets oxidized to carboxylic acid. And on reduction with HI, it will form isopentane. So option 4, that is the correct option. Next question says, when hydrocarbon A undergoes complete combustion, it requires 11 equivalents of oxygen and produces 4 equivalents of water. Let's write the general formula of the hydrocarbon CXHY. When it reacts with oxygen, the general equation is CXHY plus X plus Y by 4 oxygen, giving X CO2 and Y by 2 H2. The information given to us is it requires 11 equivalents of oxygen, which means the value of X plus Y by 4 is 11, and produces 4 equivalents of water, which means value of Y by 2 is 4. Thus, the value of Y is equal to 8. If I substitute this value here, I get X plus 8 by 4 equals 11, which give me the value of X as 9. Thus, the hydrocarbon is CXHY, which means C9H8. The answer will be option first, C9H8. Next question, an organic compound A, C4H11N, shows optical activity. When they say shows optical activity, that means this compound is chiral and gives N2 gas on treatment with HNO2. which means this compound, it definitely has a primary amine. Then only on reaction with HNO2, it will give N2 gas. It reacts with pH SO2Cl, producing a compound which is soluble in KOH. It's a Hinsberg reagent, pH SO2Cl and KOH. So let's see the options. Option third and fourth, they are not chiral, right? They are not optical active. So we are left with option first and second. Among first and second, the first is the primary amine, which on reaction with HNO2 will release N2 gas, correct? Let's write the products which will be obtained. Here is the chiral carbon making this compound optically active. On reacting with HNO2, we'll get this product and N2 will be released. Right? Then this on reaction with pH SO2Cl. How the reaction will take place. This is how what will be obtained. This, correct? Then further, this H plus will leave from here. This O negative will form a pi bond and Cl negative will be released from here. So what will be formed? We'll get pH S double bond O, NH. And this N will have this alkyl chain attached to it, right? On further reaction with KOH, OH negative will abstract this H positive and a salt will be obtained. This is how H plus is abstracted and negative K positive, and with N, this chain is attached, which is this compound is soluble. So our answer will be option first. Next question, match list first with list 2. A option is physis option. So yes, for physis option, energy of adsorption is 20 to 40 kilojoule per mole. A option matches with the second option of list 2. Then is chemis option. Chemis option is a single layer adsorption, whereas physis option, that is a multi-layer adsorption. So chemis option is a single layer adsorption. The B option matches with first of list second. N2 gas plus 3H2 gas forming 2NH3. It is a heterogeneous catalysis because we have solid phase as well as gaseous phase. Analytical application of adsorption, that is chromatography. So let's see which option is correct. This is the option A for second. Will cancel first and fourth option. A for second is in second and third option. Then B for first. So we have got our answer, which is option second. For A it is second, for B it is first, for C it is fourth, and for D it is third. So answer is option 2. Next question, the normal rainwater is slightly acidic and its pH value is 5.6 because of which one of the following? So it happens because of the carbonic acid. And how is carbonic acid obtained? By reaction of CO2 with water. So correct answer will be option 4, CO2 plus water forming carbonic acid H2CO3. Next question, in Duma method for the estimation of nitrogen, the sample is heated with copper oxide and the gas evolved, it is passed over copper gauze. It is mentioned in NCERT that in Duma method, the sample is heated with copper oxide and the gas evolved is passed over copper gauze for estimation of nitrogen. So answer will be option second. Next question, which of the following compounds are not used as disinfectants? See, chloroxylenol, bithionol, and terpineol. They are antiseptics. Whereas Vironal, this is a tranquilizer. And Prontosil, it is an antibiotic. So which are not used as antibiotic, answer will be C and D. They are not used as antibiotic. So answer will be option third. Next question. Given below are two statements. Upon heating a borax bead dipped in cupric sulfate in a luminous flame, the color of the bead becomes green. Let's see what happens when borax it is heated. We get anhydrous Na2Bu4O7. On further heating to 740 degrees Celsius, it forms NaBO2 and B2O3. That is sodium metaborate and boric anhydride. When further this B2O3 reacts with copper sulfate, we get this compound which forms CuBO2 whole twice. So this is what is obtained here, which is blue in color. They are saying the color of the bead becomes green. It is incorrect statement because the color of the bead is becoming blue. Statement 2 says the green color observed is due to the formation of copper metaborate. The blue color is observed. So statement 1 and statement 2 both are false statements. So answer will be option second. Then comes next question. Arrange the following orbitals in decreasing order of energy. In A option, we are given N is 3, L is 0, M is 0. They're talking about 3s orbital. In B option, N is 4, L is 0 and M is 0. They're talking about 4s orbital. And in option 3, N is 0, L is 1 and M is 0. They're talking about 3p orbital. And in option D, it is given N is 3, L is 2, M is 1. That is, they're talking about 3d orbital. So we'll apply Bohr's-Bury rule here, which says lower the value of N plus L, lower is the energy. So we can see the value of N plus L here is 3. The value of N plus here is 4. It is 4 again here. And it is 5 here. When the value of N plus L is same, we say lower the value of N, lower is the energy. So our answer will be 3s will have least energy, then 3p, then 4s, and then 3d. So least will be 3s, then 3p, then 4s, and 3d. Which means option D has higher energy, then option B, then option C, and then option A, D, B, C, E, which is given in option first. So our answer is option first, D, B, C, A. Next question. A hydrocarbon X with formula C6H8 uses 2 moles of hydrogen on catalytic hydrogenation of its 1 mole. On ozonolysis, X yields 2 moles of methane dicarbonaldehyde, the hydrocarbon X is. See, if this compound C6H8 it uses 2 moles of hydrogen with its 1 mole, that means this compound has 2 pi bonds, correct? So option first, it has 3 pi bonds. That means option first cannot be the answer of this question. Then we'll have to see option second, third, and fourth, what will be obtained on ozonolysis of these three. Option second is cyclohexa 1,4-diene. On ozonolysis of this, we'll get so yes, we get methane dicarbonylide. And the second compound is also same, methane dicarbonylide. So we get 2 moles of methane dicarbonylide from option second. So our answer is option second, right? Next question. Cyclohexylamine, when treated with nitrous acid, yields P. Okay. Cyclohexylamine, when treated with nitrous acid, HNO2, we'll get the product this. On heating P with PCC results in Q. PCC, it will oxidize OH group to double bond O. We'll get cyclohexanol. And while we react this with further dilute NaOH, this compound has acidic hydrogens, alpha hydrogens present. It will react with dilute NaOH and will undergo aldol condensation reaction. Heat is also mentioned here. It will go aldol condensation reaction. What will be the product? Let's see. This hydrogen, this will be abstracted, negative charge will be left here. This will undergo resonance, right? Enolate ion is obtained. In next step, this will further react with another molecule of this cyclohexanol. How? Like that. What will be obtained? Let's see. On further heating, dehydration will take place and a pi bond is obtained. This will be the final product. Let's see the options. 2 cyclohexyl ring, one ring is double bond O, and both the cyclohexyl rings, they are connected by a pi bond, which we can visualize in option first. So answer will be option first, right? Next question. Evaluate the following statements for their correctness. A option, A statement says that the elevation in boiling point temperature of water will be same for 0.1 molar NaCl and 0.1 molar urea. The elevation in boiling point, which means delta TB, it is I kBm. The value of I for NaCl, it is 2, and the value of I for urea, it is 1. That means it will be same? No, it will not be same. It will not be same. So it is an incorrect statement. B is azeotropic mixtures boiled without change in their composition. So yes, it is true. Azeotropic mixture, they boil without change in their composition. It is a correct statement. This was incorrect statement. Option A was incorrect. Option B is correct. Osmosis always takes place from hypertonic to hypotonic solution. No, it is incorrect statement because osmosis, it takes place from hypotonic to hypertonic solution. Option D, the density of 32% sulfuric acid solution having molarity is approximately 1.26 gram per ml. We have to calculate this. The formula relating molarity, density and mass percentages, molarity is 10 dx upon molar mass. Molarity is given as 4.09. Density we have to evaluate. Mass percentage is given as 32. And molar mass of sulfuric acid, we know it is 98. So when we'll calculate this, we'll get density as approximately 1.26 gram per ml. So yes, D option is a correct statement. E option states that a negatively charged sol is obtained when Ki solution is added to silver nitrate solution. It is an incorrect statement. When Ki solution is added to silver nitrate solution, AgI precipitate will be formed, and on that, Ag plus ions will be adsorbed, thus making it a positively charged sol, not negatively charged. So the correct statements are B and D. That means our answer will be option 4, which is B and D. Correct? Next question. The element playing significant role in neuromuscular function and interneuronal transmission is, so it is calcium, which plays important role in neuromuscular function, interneural transmission, cell membrane integrity, and blood coagulation. It is a line from NCERT on which this question is asked. Answer is option second, calcium. Next question. The Lewis acidic character of boron trihalides follows the order. We have to compare BF3, BCl3, BBr3, and Bi3. For comparing the Lewis acidic order of these boron trihalides, we'll first of all see the order of extent of back bonding. BF3 will have maximum extent of back bonding, then BCl3, then BBr3, and then Bi3. As the size of halogen atom is increasing from fluorine to chlorine to bromine to iodine, the extent of back bonding decreases. More the extent of back bonding, lesser will be the tendency to accept the electron pair from outside. That means lesser is the Lewis acidic character. So it will be reversed, the Lewis acidic character order. It would be BF3 will have least Lewis acid character, then BCl3, then BBr3, and then Bi3. So answer will be option second, where Bi3 is maximum, then BBr3, then BCl3, and then BF3. Correct? Next question, which of the following statements is incorrect? The malleable iron is prepared from cast iron by oxidizing impurities in a reverberatory furnace. Yes, it is a correct statement. The malleable iron is prepared by oxidizing impurities in a reverberatory furnace. That is how it is prepared from cast iron. It is a correct statement. Venarkal method, it is used to purify tungsten. No, it is incorrect statement. The Venarkal method, it is used to purify zirconium and titanium. Third statement says boron and indium can be purified by zone refining method. Yes, it is correct. Boron and indium, they are purified by zone refining method. Fourth statement is cast iron is obtained by melting pig iron with scrap iron and coke using hot air blast. Yes, it is also a correct statement. They asked us the incorrect statement. Answer will be option second. Next question. The resistivity of a 0.8 molar solution of an electrolyte is 5 into 10 power minus 3 ohm centimeter. The molar conductivity we have to calculate. So, the molar conductivity will be kappa into 1000 by m. The value of kappa will be 1 by resistivity. Value of resistivity is given to us as 5 into 10 power minus 3. And the molarity is given to us is 0.8. It will be 10 power 6 into 10 upon 5 into 8. That would be 1 by 40 into 10 power 7. We will simplify it. It will be 25 into 10 power 4 per ohm centimeter square per mole. So our answer will be 25. 25 into 10 power 4 per ohm centimeter square per mole. Correct? Next question. The number of molecules which gives haloform test among the following molecules is. So, the identification of the molecules showing haloform test is they must have this group present or this group present. Correct? Let's search in this. Here I have C double bond OCH3 methyl ketone present here. It means this will show positive haloform test. In second option, this group methyl ketone or this alcohol that is not present. It will not show haloform test. It will give negative haloform test. Then in third option, I again have methyl ketone. It will show positive haloform test. In fourth option, it will not show positive haloform test. It will show negative haloform test. In fifth option, I have this alcohol. So it will show positive haloform test. And in next option, it doesn't have a methyl ketone. It will not show positive haloform test. So the number of molecules which gives haloform test among the following molecules is 3. 1, 2, and 3. Correct? Next is the number of alkali metals from lithium, potassium, cesium, and rubidium having ionization enthalpy greater than 400 kilojoule per mole and forming stable superoxide is. So the ionization enthalpy for lithium is 520 kilojoule. For potassium, it is 419 kilojoule. For rubidium, it is 403 kilojoules. And for cesium, it is 376 kilojoule. So they asked us having ionization enthalpy greater than 400 kilojoule per mole. So I am left with option lithium, potassium, and rubidium and forming stable superoxide. Out of these four, potassium, rubidium, and cesium, they form stable superoxide and lithium forms monooxide. But I have two conditions here, having ionization enthalpy greater than 400 kilojoule as well as forming stable superoxide. So that would be potassium and rubidium. That means answer will be 2. There are two elements out of these four, that is potassium and rubidium, which have ionization enthalpy greater than 400 kilojoule per mole and forming stable superoxide. Next question. If the CFAC of TiH2O whole 6 3 plus is minus 96 kilojoule per mole, it is an octahedral complex. This complex will absorb maximum at wavelength what? Okay, so Ti water 6 3 plus. That means Ti is in 3 plus oxidation state. Its outer electronic configuration will be 3d1. The formula to calculate CFSE for octahedral complex is minus 0.4 into number of electrons in T2G plus 0.6 into number of electrons in EG delta O. Okay. Now, our electron distribution will be like this. EG, T2G, we have one electron in T2G. That means minus 0.4 into 1 plus 0.6 into 0 into delta naught. That will be minus 0.4 delta. And its value given to us is minus 96 kilojoule per mole. We'll convert it into joules and it is given for 1 mole. So we'll divide by 6 into 10 to the power 23. Correct? Now we can write this delta O as Hc by lambda. This lambda is the wavelength which is asked to us. We can put the values of HMC and calculate this value of wavelength. Let's do it. It will be 96 into 1000 upon my 6 into 10 power 23. 1 second. Let's write it first of all. 96 into 1000 divided by 6 into 10 power 23 equals 0.4. We'll put the value of H. 6.626 into 10 power minus 34 into 3 into 10 power 8 divided by wavelength. So when we'll calculate this value of wavelength, it will come out to be 480 into 10 power minus 9, which means 480 nanometer. We were asked in nanometer, so our answer will be 480. Right? So answer to question number 54 is 480. Next question. The enthalpies of formation of CCl4, H2O, CO2 and HCl are given. The enthalpy, magnitude of enthalpy of the reaction. Okay. So we are given the delta H formation of CCl4, that is minus 105 kilojoule per mole. Delta H formation of water is minus 242 kilojoule per mole. Delta H formation of CO2 is minus 394 kilojoule per mole. And delta H formation of HCl is minus 92 kilojoule per mole. We have to evaluate the magnitude of enthalpy of reaction for this. For this, delta H reaction will be the summation of change in enthalpy of products minus summation of change in enthalpy of reactants. For products, we have CO2 and 4HCl. The value for CO2 is minus 394. And for HCl, it is minus 92. But there are 4 HCl, so 4 into minus 92. For reactants, we have CCl4 and H2O. For CCl4, it is minus 105. For H2O, it is minus 242, but it is for 2H2O. So 2 into minus 242. Correct? So it will be minus 394, minus 368, minus of minus 105, and minus 484. This will be 589 minus 394 minus 368. The value will come out to be minus 173 kilojoule per. So the answer to this question is minus 173 kilojoule per mole. Correct? Next question. Question number 56. At 298 Kelvin, the solubility of silver chloride in water is 1.434 into 10 power minus 3 gram per liters. And they're asking us the value of minus log Ksp for silver chloride. AgCl solid will form ions Ag plus and Cl minus. If the solubility we are considering for silver chloride as S, so we'll have Ksp as S squared. And S is given to us as 1.434 into 10 power minus 3 gram per liters, right? First of all, I'll convert this to mole per liter. So for that, I'll have to divide it by the molar mass of AgCl. Molar mass of AgCl would be 107.9 plus 35.5, which will be minus 143.4 grams. So it will be 1.434 into 10 power minus 3 divided by 143.4 mole per liter. The answer to this will become 10 to the power minus 5 mole per liters. Correct? We were asked KSP. So what will be the value of KSP? It will be S square. So 10 power minus 5 whole square, which becomes 10 power minus 10. We were asked minus log KSP. If the value of KSP is 10 power minus 10, the value of minus log KSP it is 10. They asked us the value of minus log KSP for silver chloride, and the answer to this will be 10. Correct? Next question. Assume carbon burns according to following equation: 2C solid plus O2 gas giving 2CO. When 12 gram carbon is burnt in 48 gram of oxygen. It is given to us as 12 gram and it is given to us as 48 grams. 12 grams would mean 1 mole, 12 by 12. The molar mass for carbon and the molar mass for oxygen, 48 by 32. This will be 3 by 2, that means 1.5. Thus, carbon is our limiting reagent. Correct? Now, 2 moles of carbon is reacting with 1 mole of oxygen to give 2 mole of CO. Correct? So 2 mole of carbon is forming 2 mole of CO, carbon monoxide. We have 1 mole of carbon. So how much CO is obtained? 1 mole. We were asked the volume of carbon monoxide produced. 1 mole of carbon monoxide at STP. What will be the volume produced? The volume of CO produced at STP for 1 mole is 22.7 liters. It is given into 10 power minus 1. So answer will be 227 into 10 power minus 1 liters. Correct? We were given the molar volume as 22.7 liters per mole. So our answer will come 227 into 10 power minus 1 liters. Right? Next, the rate constant for a first order reaction is 20 per minute. The time required for the initial concentration of the reactant to reduce to its 1 by 32 level is. Okay. So first of all, we'll calculate the number of half-lives. That will be this. As per this formula, and n will come out as 5. So the number of half-lives is 5. Okay. So we have to calculate the time required for initial concentration of reactant to reduce to its 1 by 32 level. So we have to calculate the time required for the reactant to reduce to its 1 by 32 level. That would be 5 into T half, 5 half-lives. And the value of T half for first order reaction, that is 0.693 by K, the rate constant, whose value is given to us as 20 per minute. That is given to us as 20 per minute. Correct? So we'll solve this. 5 into 0.693 divided by 20. Correct? We'll solve this. We'll get the answer in minutes. So when we'll solve this, we'll get 17 into 10 power minus 2 minutes. We were asked the value into 10 power minus 2 minutes. So our answer would be 70. Right? Next question. A sample of a metal oxide has formula M.83O1. I can write it as M83O100 also. No problem. The metal M can exist in two oxidation states, +2 and +3. Let the number of +2 ions as X. So the number of +3 ions would be 83 minus X. Very simple. We have to calculate the percentage of metal ions existing in +2 oxidation state. We have to calculate the percentage. So how will we do this? We'll do the net charge balancing here. Total positive charge equals total negative charge. So the total positive charge would be +2 into X plus +3 into 83 minus X. That is equal to 100 into -2. The charge on oxygen, which is -2. So 2X plus 249 minus 3X equals minus 200. This will be X equals 49. Correct? We had to calculate the percentage of metal ions existing in +2 oxidation state. Percentage of metal ions existing in +2 oxidation state, it will be 49 divided by total 83 into 100. Correct? Solving this, we'll get around 59%. So our answer is the percentage of metal ions existing in +2 oxidation state, that is 59%. The last question, amongst the following, the number of species having the linear shape. First given to us is XeF2. XeF2 has 2 bond pairs and 3 lone pairs. It has hybridization sp3d, and due to the 3 lone pairs, the trigonal bipyramidal geometry will be distorted to the linear shape. So it has a linear shape which is asked. Then we have I3 plus. I3 plus, it has 2 bond pairs and 2 lone pairs. The hybridization is sp3. And due to the presence of 2 lone pairs, the shape is V shape. It is not a linear shape. Next is C3O2. The structure of C3O2 is this. Here, all the carbon atoms, they are sp hybridized. That means the shape is linear, right? Next we have I3 minus. I3 minus has again 2 bond pairs and 3 lone pairs. For 2 bond pairs and 3 lone pairs, the hybridization is sp3d. And due to 3 lone pairs, the geometry will be distorted to linear shape. It is also linear. Then we have CO2. The shape of CO2 is this. Here, the shape is also linear. Correct? Next we have is SO2. In the case of SO2, we have sp3 hybridization, right? In this also, due to presence of 2 lone pairs, the shape becomes V shape. Next we have BeCl2. In the case of BeCl2, we have sp hybridization and the shape will be again linear. Correct? Next we have BCl2 negative. BCl2 negative. For BCl2 negative, we have sp2 hybridization, and due to presence of one lone pair, the shape will become again V-shaped. So we were asked how many of the species have the linear shape. So XCF2 has a linear shape, C3O2 has a linear shape, I3 negative has a linear shape, then CO2 has a linear shape, and then BeCl2 that has a linear shape. So total molecules or species having linear shape is 5. Right? So thank you very much, everyone. Thank you.